Okie dokie. So we are recording. This is the follow-up to the week 9 live lesson. In this example, of course I have to clear my throat, sorry. Okay. In this example, we want to find the surface area of this composite figure. So what we're literally going to do is we're going to take all of these faces of the figure and just add them together. Okay, that's it. That's surface area. So I see a whole mess of rectangles. So we'll start there. So let's do this rectangle in the front here. I gotta move my little pen thing. There we go. So it looks like it says the length of this one is 89. And the width would be right here. It would be 41. So I'm going to go 41 times 89. Oh my gosh, you'd think I'd be smart and have my calculator next to me when I'm going to do a live session like this. My goodness. Okay, phone calculator coming up. So we're going to go 89 times 41, and we get 3,649. That's going to be the area of the front. And since it's parallel to the back there, the back would also be 3,649. So now let's do this side here. We're going to go 96 times 41. Because area is length times width. 96 times 41 gives us 3,936 square yards. And then again, it would be the same on that parallel side there. Okay. So we've got like all the sides. Let's think about the bottom of the figure. The bottom would be this 96 times this 89. You got to be careful and kind of visualize like a Kleenex box or something. Because the 41, that's going to be the height of the figure. We don't want to mistake that with the bottom. So for that one, we're going to go 96 times 89. 96 times 89. That's going to be 8,544. Okay, so we have everything around. Now let's think about these sides here. So we're going to go, oh my gosh, my mom wants a hammock for her cat and she keeps texting me. Stop texting me, Mom. Gosh, weirdo. Okay, so in this one's going to be another 96 times 41. And we kind of already did that. That's right here. So this one's also going to be 3,936. And then it's definitely going to be the same on the other side there because they match up. Because this side's 96, this would also be 96. So it's 3,936. And we're almost done. Now we got the top. The top is going to be this 9 times this 96. So we're going to go 96 times 9, and that's 864. And now we just have the two trapezoids, and since there's stuff written over there, I'll just write 2 trapezoids. So for that area, we have to take the height of the trapezoid times the two bases added together. It looks like it's going to be that 9 and that 89. And then divided by 2. So 9 plus 89 is 98. Times 9 is 882. And then I divide by 2. And we get 441. And then there's going to be 2 of them because there's a back side as well. So 441. So my final area is I have to add all of this stuff together. Okay, it looks like I have 1, 3936, 2, 3, and 4. So we have 4 3,936s. So we can go 4 times 3936. And then we have 3936. Okay, then we have, see, this is the hard part. You got to keep track of it. So then we have, so that's this one, this one, this one, and this one. Then we have 1,864. And then we have 2 of the 441s. And then we have 2 of the 3,649s. Isn't that crazy? This is a crazy problem, you guys. So I think we got them all. Yeah, okay. So 4 times 3,936 is 15,744 plus 864 plus 2 times 441 and then 2 times 3649. And then we're going to add them all together. So 15744, blah, blah. I'm just not going to say it because it's going to confuse everything. Plus 864, 882, 7298. So we get a surface area of 24,788 square yards. Whew, it's a lot of work. I'm tired now. Just kidding. So when you find the surface area of those figures, you're just finding the figure of every face, the area of every face, and then adding it together. Same deal with volume. You're going to need some volume formulas, though, because I don't know what those are. So we need, what is our 3D formulas? Here we go. Oh, of course that had a pyramid and I don't have that on there. Okay, let's look that up. So I'm going to type in volume of a pyramid. So that's going to be length times width times height divided by 3. That's what that is. Okay, so we'll go ahead. Here we go. So we have, in this figure, we have a pyramid plus a prism. So we're going to find the volume of each figure and just add them together. So for the prism on the bottom, I'm just going to go length times width times height. That's it. And then for the pyramid, I have to go length times my width times the height of the pyramid and then divide by 3. So I'm going to go length times width times the height of my pyramid and then divide by 3. So that's all we're doing. We're just combining a whole bunch of formulas. So we get 1,444 when you do this guy here. Not 91. 51. What? That's crazy. No. 19 times 19 times, there we go. 13. 4,693. And then we're going to add 1,444. So we get a total volume of 6,137 cubic feet. So, yay, we're done. We're just adding stuff together. got this. Okay, so for this one, we have to talk about perimeter and how it relates to the area here. So when you have a scale factor of two similar figures, that means their ratio of their perimeters is also the same. So whatever the scale factor is, when you add up all the sides of one figure and then add up all the sides of another figure, and then compare them, you would get the same ratio. The areas, the ratio is squared. So you would take the scale factor and then square it to see how the areas compare. I'll show you what I mean. It's kind of a weird concept here. So here we have two similar figures. Okay, we're given that they're similar. So what we're going to do is we're first going to figure out the scale factor of the larger figure to the smaller. So they want us to start big to small. So we're going to match up two sides to figure out that scale factor. I'm thinking this 15 matches up with the 12. I can double check that because of the similarity statement here. Side CD should match up with HI. CD, HI. So it does work. So for part A, I'm going to compare CD to HI. And it looks like we get a scale factor of 15 out of 12. You might be saying, whoa, Jen, I think we could divide by 3. I think you're right, guys. If we divide by 3, we get 5 over 4. So we get a scale factor of 5/4. So now, given the scale factor, we want to find AB. So we know one side is AB. We know 5/4 is big to small. We want to find AB, that's the big side, and compared to AB, it looks like it matches up with this 4. Oh, look at that. Same denominator. The only way it would work is if AB is 5 as well. But if you did not spot that, don't feel bad. I'm tired too at this hour. We would multiply what is diagonal and divide by what's left over. Then we want to find the ratio of the perimeters of the larger figure to the smaller figure. That's the same as the scale factor. So that works for the perimeters as well. I don't think I'm spelling it right, but whatever. And so that would be like if we knew all of the sides of those figures, I could add them all up, get the perimeter, add up all the sides on this one, get the perimeter, and if I compared it, knock it off, Delilah, my cat's hissing, cut it out. And if I compared it, then I would end up with the same scale factor. Then I want to find the ratio of the areas of the larger figure to the smaller figure. So large to small, and this is areas. So all I'm going to do is I'm going to square the scale factor. That's what you do if you want to get the ratio of the areas. So we get 25 to 16. And that's it. That's all you can do. Easy peasy. It's a little weird, I think. A little weird. Okay, so applying this, I thought this was a really weird question. That's why I wanted to go through this one. I'm actually going to pull up the Math Excel stuff with it, just because it's super helpful. So during the summer, a group of high school students cultivated a plot of city land and harvested 13 bushels of vegetables, which they donated to a food pantry. Next summer, the city will let them use a larger plot of land that is similar to the previous plot. So first we got to think about in the new pot, sorry, I'm getting ahead of myself. Each dimension is 2.5 times, oh my gosh, my kitty tried to jump up on me. Come here, baby. Get her. There she is. Oh, you can't see. I don't have the camera on. But that was so cute. And now she jumped down. Fine. So next summer, blah, 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 new plot, each dimension is 2.5 times the corresponding dimension of the original plot. How many bushels can they expect to harvest next year? So first thing we're going to need is a ratio. And I'm purposefully talking slow because I want to pull up the textbook and just make sure. No, 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 kitty, don't eat cords. That I am thinking about this correctly. Oh my gosh, why can I not see a textbook? There we go, textbook. It's here, it's here, stay with me. Is this creepy yet? This is what I do. I go between the textbook and this. Okay. So first thing we're going to need is a ratio. So for one plot of city land, they harvested 13 bushels per one plot. In the new plot, it's 2.5 times bigger. And I believe all we're doing is just doing some multiplying here. I'm double checking because I don't remember. Come on. Oh, hi, baby. Yeah, you're getting my foot there. Okay. You know what, guys? I think yeah, here we go. I swear this is my confusing myself in the video. What? Not pulling up the right textbook, guys. Guys, what's happening here? Here we go. Couldn't get the right one to pull up, but I got it. It's all good. All right. Beautiful. Okay. So what we want to do, okay. So yeah, that's what they did last year. So the change in the dimension, it's going to be 2.5 times the corresponding dimension. So we put this dimensional change, that 2.5 times, because that's the change, that would actually be the ratio that we're going to use. Okay, and now what we're doing is we're talking about plots of land and bushels of vegetable you can get from plots of land. And since we are dealing with plots of land, okay, this is all our veggies growing and all that good stuff. Anyway, what we're doing is we're talking about area with plots of land. So what we want to do to this ratio is we want to square it to actually get the area ratio. So in the new plot of land, the areas will have a ratio of 6.25 to 1. And we can take that 6.25 times as much land and we can multiply it by 13. So we would get about 81 bushels. So this is an important ratio to know because this is what they usually get. But because this talks about our change, that turns into the ratios. And then we're just squaring it and multiplying by the number of bushels they got last time. Sorry about that intermission, guys. I got a little frazzled. Okay, so the triangles at the right are similar. what is the scale factor and what is the ratio of their perimeters? So right now we know the area, okay, and we're just going to go first triangle to second. Oh, go back. It's not time to go yet. No. So we're just going to go first triangle to second triangle like that. Okay, so we're going to go 50 centimeters squared to 98 centimeters squared. We're just doing that because they gave the smaller one first, and they didn't really tell us which way they want us to do it. So from there, first thing I notice is, I'm just going to simplify them because I can. So we end up with 25 centimeters squared over 49. Oh, 9 centimeters squared. Oh my goodness, look at that. Those are perfect square numbers. So what I can do now is, if I took the square root of those numbers, that would give me a ratio of 5 centimeters to 7 centimeters. So we had to simplify to first be able to square root. So you might have to do that. But once we square root it, we can get back to the perimeter ratio. And the perimeter ratio is the same as the scale factor ratio. So we would just say it's 5/7. That's it. So just try and keep that straight. Remember, square the ratio if you need to get to the area, and square root it if you need to get back to the perimeter. But thanks for joining me. You guys have a lovely evening.